Welcome back for today's session called as Text Representations in NLP. So today we will be discussing about some basic vectorization approaches on how we can represent the text in NLP. Earlier sessions we have discussed about what is NLP, the challenges, how the NLP is being used in real-time applications, what is the NLP pipeline, what are the basic pre-processing steps, how to perform tokenization and all. Now, today we'll be seeing about the text representation, how the text is being represented and understandable to the machine learning or the computer processing. So, text representation. How are we representing a text so that a machine or a computer system can understand? Usually, all the computer systems or any of the processing models can understand the form of binaries of zeros or one. How are we making these representations of the textual form, which is in the form of text, PDFs, images, text and all? How are we allowing it to be understandable to the machine learning or an NLP processing model? For that, we'll be seeing now like this. So, what do you mean by text representation? It is a process of, it is a methodology, it is a technique of converting the text into numbers so that the computers or our machine learnings can understand. How are we representing it? In the form of numbers. Okay, suppose I have given a piece of text. This scheme of text or this phrase has to be in the form of a raw text which is being given by the users. Next, it has to be mathematically represented and understood by the system. Okay, by the system. This entire process, we call it as representation of a text. How the words, how the documents, how the individual sentences, the collection of all these words are being mathematically represented in the vector. For that purpose, we have these text representation techniques. In this session, we will be working out on the vectors representation techniques. How the words are being represented in a high dimensional space in the form of the vectors. Before I proceed to these points, let us see one example. I love NLP. For this, the computer systems cannot understand this raw text as I love NLP. It has to get it analyzed and converted in the form of a numerical form. Let us say in this example, I is one token, love is one token, and NLP, which is in the low case sentence form. Yes. When I am doing it, the text pre-processing and all. Now, I have to map these words into the numerical form in a high dimensional space in the form of zeros or ones or whatever. I can also give my own assignment like 1, 2, 3 and all. This vector, this representation of a raw sentence as I love NLP has now been in the form of a vector representation. This is how the computers can understand of what we enter and how it is being analyzed internally. Got it? How is this representation being done in the vector form? What are the techniques? For that, we'll be having for the today's session. Vector space model, basic vectorization approaches. In that, we'll see. You also have distribution representations, how the words are being distributed in the other documents and being mapped, and how they are being clustered or embedded with the other usage of the occurrences of the words. Next, how those words are being distributed beyond the characters or beyond in the form of sentences. Fine. So what do you mean by vector space model? It is the procedure, it is a mathematical framework where we are representing documents and terms in the form of a high dimensional space. Yes, we can represent the documents, terms in the form of a vector having the terms versus documents. In this example, we can say this. Yes, suppose I have an apple, I have a fruit. All this I can show it all together in a form of a same positional which is being mapped. Suppose I say I love burger, I love pizza. Burger is a junk food. Children like to eat burgers, pizzas during parties. So the words like burger, pizza, food, and all comes under one common. So how are we going to map? How are we going to relate all those common words to at one place? This is what we call it as our vector space models. How is this vectorization being done? So for that, in NLTK and we can import the library called as counter vectorization, where we are counting and representing our words in the form of the vectors. Suppose I love NLP. NLP is a great. I love machine learning. So I have the unique words as love, NLP. Next I have great, I have machine, and I have learning. Yes, got it? How is this? So first I have to represent it in the form of the vectors. Next I have to make the model to me map from the common corpus and transform it. And I have to take out the features, important one, in the form of this. So zeros or ones and all. So if you could see here how it is being arranged, as I have mentioned, these are all my available terms, but the unique terms are the love, NLP, machine, great, and learning. So after removing the stop words and all where I is not essential, this is how the output is being given or being rendered as a featured output or the featured result in the form of the vectors from these raw text called as how, with the which is there with the double quotations or which is there with full stop, and you also have quotation marks. From this is how it is being there. So for this I have I as one collection, love as one vector form. Next for NLP I have, for is I have, for great I have, for machine I have, and for I love NLP, wherever you have the word, it is being represented in the form of zeros or ones. This we call it as vectors, and this is how the machines can understand. Got it? So what are the techniques you have? In vectorization, one hot encoding, bag of words, bag of engrams, and TF-IDF. I have a very small example, one more example we have taken here. The movie was very good. How was the movie? It was very good. So what are my important features? Now, when we talk about the images, if I talk about the image of a cat image, it has eyes, it has features, the skin, the texture, the color, the image, the size and all. But how are we going to make all the features in the form of a text and all? We are not having any image in any size and all. This is being measured in the form of the features where you have how many words, how many terms are there, which term has occurred more, what is the importance of each term. Suppose in this I am only talking about the movie. The movie's actor was so and so. So the occurrence of the existing words which comes after movie and all are important for me. See, in this we could see the word count is 5 because I have 1, 2, 3, 4, 5 terms, 5 words. And my important term is they are talking that how was the movie? It was very good. It is a positive review. This is how it is being analyzed. It is being sentiment. For the image recognition and all, we are doing it. What is the classification and all. But in the textual come, it has to see how the opinion, what is the text, how it is being analyzed. So what here, how am I telling it's a positive assignment? Because of the availability of the word called as adjective, which is a part of speech tagging called as good. So this vector space models helps us for us to make the available raw textual files in the form of a vectors, and then doing the feature engineering identifying the important features from the available documents or text. So what is one hot coding is of course a traditional method where we are representing in the form of binary vector form, which is in the zeros or 1. If the document is available, then it is 1. If it is not available, it is 0. So here I love NLP. So I it is available, so it is 1, the rest is 0. I is being considered as one vector, love is being considered as one more, and NLP. So for love, it is like this. For NLP, it is. So in the initial, the other 2 are zeros. In the next vector, it is being in the center, the rest is being 0. In the third sentence, it is NLP is in the, and this is how. Now, this is my vector representation. 1, 0, 0, 0, 1, 0, and 0, 0, 1. This is the vector representation for I love NLP. This representation, we call it as one-hot encoding. It's a very traditional, very usage and very popular technique, but they are having some limitations called as it may not be suitable for large vocabularies. I may be very getting a good results when the data set or the very when I'm working with some small sentence frames and all, but it may not go, and it becomes complex when the vector size increases. For me to write a paragraph of 30 or 40 lines, maybe the vector size should go into a dense one, which may not be properly suggestible when we are using for the one-hot encoding. And also there is no meaning for the respective terms or the words that are being used for one-hot encoding. So that's why we have the procedure called as bag of words. In the bag of words, it tries to identify and consider how many times each term or each word has been existing available in the given text. So I have a paragraph about some review. I love this movie, it's sweet, but so and so and so. Now, what is this bag of words representation? How many times the words have been occurred? Suppose the movie, how many times it has occurred? Sweet, how many times? How many times it has occurred? Fun, how many times? I could see so many das are there here. So I has occurred more number of times. Several you have, happy you have. Likewise, all these words are being traced out, collected in the form of a bag, and then being represented in the form of the counts. You have 5 times. Next, it you have 6 times is being available. At how many times? These are all the 1. Means the most occurred term here is the I. They were. This is how the words are being counted and represented in the bag of words. Whereas in one-hot coding, suppose I have this set of sentences, you have some 6 documents, it is being just writing if it is available, yes or else no. In the bag of words, it is also trying to say how many times that word has also occurred. That we call it as bag of word representation technique. See, you could see this example. Natural language processing is amazing. I love NLP and machine learning. We have text processing with bag of words is simple. And this is how I have roughly a 3 sentences document which I have. For that, how does this bag of words is going to form the vector is, it forms in the alphabetical wise where A, next B, C, D and all so words. Next, it will try to count how many times that word has been existing in the D1. So this is how it is being represented. You have 1, next, again the P has been next, and then it counts, This is what it happens in the bag of words. This also. So you are breaking the text into words, next identifying the unique words, then counting or representing into vector form. Each column we have a unique word, then we are listing, then we are counting. Then this is the difference between one-hot encoding and the bag of words. Sometimes there is also limitation with bag of words such that if you could see in this case, cat chases mouse, mouse chases cat. there are syntactically, you have 3 words even in the document 1. You also have 3 words in the document 2. But though you have the identical number of vectors, still there may not be syntactically same. Their meaning is different. Here it was talking, cat has eaten the mouse, has chasen the mouse, but here the different. The scenario is different. The semantic version of these two sentences is different, though the vector frames are similar. For that purpose, we need to see or identify with the combination of these words. For that, you have bag of n-grams. So what do you mean by bag of n-grams? It is also a text representation method, but an extension of bag of words, okay, where instead of just trying to count the individual words, here we are also counting with the form of a pairs with some combination. Maybe in the form of a set of 3, a set of 2, or a set of 4, or n. That we call it as bag of n-grams. Suppose you have the same sentence, cat chases mouse, and you have the other sentence, our D2 was mouse chases cat. So for this, if I add with the combination like this, cat and chase as one pair, chase and mouse as one pair, similarly mouse and chase as one pair, chases and cat like this, and then do the vector representation, then I may have a different scenario or a different understanding to analyze those document text. That's what happens in the bag of n-grams. Here, cat chases is 1, chases mouse as 1. This is a bag of n-grams where n value is 2. In the above case for bag of words, D1 and D2, though they have an identical vectors, their meaning was different. In this scenario, in the bag of n-grams, we could see that D1 and D2, the vectors might be different, but still it is trying to solve our word order ambiguity. So, what is the main difference between bag of words and bag of n-grams is that in the n-grams, it follows the order. This order is not so in the bag of words. It is being lost. It only counts and this but may not give a syntactical meaning, whereas in bag of n-grams, it will also follow the order, and to some extent the ambiguity is being solved by using bag of n-grams. Here also you could see for the n-grams 1, I have this text, I love machine learning. So in the unigrams, it is being counted at once, whereas for bigram, where it is the set pair is 2. So I love is one combination, love machine is one combination, machine learning is another combination. For trigrams, you have like this, I love machine as one set, machine and then learning and then the next part. So this is more effective when compared to one-hot encoding as well as bag of words. The next comes about TF and IDF. Term frequency versus inverse document frequency. This is also a traditional, most existing technique on how we can represent the text in the form of the numbers or the vector form. And it is better when compared to the bag of words and as well as bag of n-grams. In bag of n-grams, we need to give the limitation of the n size, whereas here you are having some mathematical formula to calculate term frequency and also to calculate inverse document frequency. That we will see. So what do you mean by term frequency? It is the measure to count how many times that term or that word has been existed in an available document. Suppose in this scenario, in the slide, I might have a bag of words as I have a version, I have improved, I have, and so many words are existing. Now I will try to determine how many times this word has occurred in that document and by total number of words. Suppose in this slide scenario, I have say 15 words. Out of 15 words, suppose my improved version has existed 1, off has come 2. So 2 by 15 is my term frequency. How many times this word has existed in the available document. So what is the weightage? What is the importance of TF and IDF is that it gives more preference not to the existing count of the terms and also how they are being weightage accordingly with the other terms. So as I have mentioned, if a term or a word is number of times, this is number of times that word is being appeared in the document by total number of terms. So in my entire thing, if I have 100 documents, 100 terms, my particular words have been repeated 5 means it is 5 by 100. This is term frequency. Inverse document frequency, this is a proportion of the document such that which that document is containing that particular term. For that you have log of the number of documents. I have in a one document, see, I am writing it as one. In one document, I have 100 words. Out of 100, 5 words were repeated. That is the 5 term frequency. Likewise, I have 1000 documents. So for that, log of, I have number of documents by number of documents in the corpus that contains. Not only in this existing document, if that same terms are also being available in 1000 documents, then I will be making all together as formula. Inverse document frequency is equal to log of number of documents by the number of documents into this. I'll show you with one scenario, with one example, then we can see. Finally is the formula TF-IDF, which is a multiplication of term frequency into inverse document frequency. I have a term T which is appearing 20 times in a document. That's what I have mentioned. And likewise, I have total 100 words. That's what I was mentioning. So it is 20 by 100 is 0.2. This is my term frequency. In inverse documents, similarly, I have a collection, total collection of my related documents. Suppose related to social, related to history, related to geography. All are related to the terms, common as. So all likewise, I have 10,000 documents. So what are we doing in IDF is log of 10,000 by 100 is nothing but 2. This 10,000 is total number of documents are 10,000. Likewise, and each in it is number of words is 100 and each might it is 2. So 2 into 0.2 is my total IDF value. So what is the significance of TF IDF is it gives illustrates and separates or gives a distinction between the common words and the rare words. Maybe the rare words may have more importance, more weightage. It gives a weight. It gives the significance for the words called as adjectives and all. Maybe few other words may have less significant. In this, I have a set of 6 documents. Cat chases mouse, mouse chases, etc., etc. So what is here significant term is meat, cheese and fish. The other terms called as other words which I have cat, eats, chases is a common thing. Every cat will have, it will chase for the food and all. But it has eaten a fish, it has eaten a cheese, a meat is all the things. This is how it is being. So it highlights the important terms and also gives the less significance to the low level terms. So from these 6 documents which I have, this is my vector. You have cat, you have mouse, you have chase, etc. Of course, in this it is being arranged alphabetical sequence. So I have the terms like cat, cheese, meat, mouse, chases, etc. So I have listed it out, unique terms. Next, cat has existed in 1, in the document 2, in the document 3 and also in the document 6. So I have total count is 4. Next, for the chases, it has existed here. Similarly, in the D6. So it is 3. Likewise, for mouse, it is available in document D1, D2 and D5. So it is 3 and so on. Maybe the terms as cheese is existed only once in D5, D4 and so on. So this is one task. Next is the step is how are we determining the IDF, inverse document frequency. For that you have log of total number of and by this value. So here for our purpose we are using the log 10 as the base value. So for that, since I have total number of documents 6 by how many times this word cat was appeared, you could see here it is 4 times. So it is log of 6 by 4 to the base of 10. it is 0.8. Similarly, for chase, it is 6/3 log. It is 0.3. Similarly, for cheese, you could see it is log of 6, since we have total as 6 documents, but it was occurred only 1, so it is 1. So it is 0.7. Now, these values have to be multiplied with your TF. How are we calculating the TF? It is respect to individual document. Means in this, what is the significance? It is, suppose I have cat eats fish. So I have total versus 3. So it is 1/3. 1/3 into 0.18. How do you get this 0.18? This was with respect to the document IDF. So IDF into the TF is 1/3 into 0.18. This is what you have got. Similarly, for eats also I have to do. Similarly, for fish also. Cat has come only 1, eats has come only 1, and fish. So it is 1/3 into, what was the IDF for these terms as cats, eats, and fish? It is 1/3 into this. This is how you have to got the values for total of TF IDF. Similarly, I can do it for D1. Similarly, I can do it for D2, for D4, for D5, for D6. Here, for D4, we have done. For D4 also, it is 1/3 into the IDF values which we were doing with respect to total as 6/, log of 6/. So this is how you have got. Similarly, for cat chases mouse also we have done. We could see that in the analysis here, the term fish has got more weightage. Because for the fish, it is 0.26, whereas cat is the common thing, it has 0.06. In this scenario also, meat has got the more weightage. Yes, so the terms are being arranged and in the order of their weightage into low and high. So this is how today we have seen the basic vectorization approaches as one-hot encoding, about the bag of words, a bag of n-grams, and TF IDF. So overall, as a summary is that one-hot encoding is having an issues with scalability and lacks the semantic. The bag of words may not be able to capture the semantic meaning, may not follow the order. Whereas the n-grams may follow the order, but also it may also not give the preferences to the weights of the terms. Whereas TF IDF is a good approach which will give the preference and also to the weightage to the important terms and less important terms. So in the next session, we will be seeing about the distribution approaches required to represent text, which involves embeddings, maybe in terms of pre-trained embeddings and also our own, with some real-time examples. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.